As the thick fogs rise, America's northwest is wriggling from the grip of winter. The forest has long shaken off its white burden. Just the high peaks are still covered in snow. Big cats roam the valleys of spring. And the huge Roosevelt elk are beginning to recover from the long, harsh winter months. Spring has clearly arrived. Bald eagles soar above Spirit Lake. Towering above it all is one of America's most beautiful summits, Mt St Helens. But on the morning of May 18th, 1980, there's a different scene. Within minutes, a volcanic explosion has turned the land into a moonscape. 57 people have died. Woodland and wildlife have suffered extreme mortality. It was the most violent eruption on American soil in modern times. Will the devastated land ever recover from this cataclysm? Will nature be able to recolonize after this major disaster? Charlie Crisafulli has spent much of his life studying the area. For 3 decades, he and his fellow scientists have worked to answer these questions. They have witnessed nature's astonishing comeback to Mt St Helens, a story of life from zero. Soon after the volcano's eruption, US Congress took a historic decision. Mt St Helens was declared a protected area with sections reserved primarily for research and limited public access, turning it into the world's biggest research lab. Biologist Charlie Crisafulli, a US Forest Service ecologist, has studied the site ever since.
When we arrived at Mt St Helens in 1980, I had come from an old-growth forest that was very comprised of large trees, and it was very moist and humid. And when I got out of the helicopter here, I was astonished, awestruck, simply could not believe what had happened. There was no life anywhere I looked. And immediately came to mind were the questions, could have anything survived this type of impact from a volcano? And if so, would those organisms persist? And finally, how would life possibly come back to a state like it had been before, or would it even do that at all?
Mt St Helens lies in a geologically very active zone belonging to the Pacific Ring of Fire. This volcanic belt runs around the entire Pacific Ocean, from the Bering Strait to New Zealand, and from South America to Alaska. Along this belt, ocean floor is slipping under continental plates, a process accompanied by earthquakes and volcanic eruptions. Mt St Helens is sitting on a hotspot. It forms a stunning foursome together with 3 other volcanoes. Mount Hood to the south, Mount Rainier to the north, and in the east, Mount Adams. Underneath Mt St Helens, the tiny Juan de Fuca plate is slipping below the North American continent. cracking it in places. Magma creeps to the surface through these cracks, clogging them so that gas pressure can build up tremendous energy. That is exactly what happens in the early hours of May 18th, 1980. This is a reconstruction of the cataclysm in real time, based on 24 photographs. 8:32 a.m. An earthquake triggers a slide of the entire northern flank, sending masses of soil, rocks and vegetation, snow and glacial ice thundering downhill. Freed from the weight of the slope, the volcano's pent-up energy is unleashed. Following the landslide, a fiery cloud of gas, shattered forest debris and crushed rock surges across the land, flattening 370 square kilometers of forest. Temperatures are extreme, 300 to 500 degrees centigrade. As the landslide hits Spirit Lake, it whips up the water into a huge wave. It races across the lake, surging up the opposite mountainside. Only from space does the scale of destruction become apparent. Within just a few minutes, the volcano has devastated an area the size of Salt Lake City. The blast zone is entirely covered in ashes. In the weeks following the eruption, scientists were on site assessing the situation and designing research plans, among them young Charlie Crisafulli.
Nothing could have prepared me for the sights and sounds that I saw when I got here, because it was complete and utter barrenness. It was just ash, and there was no sign of life whatsoever.
These early expeditions were risky. At any moment, the volcano could have erupted again. At that time, just a few kilometers from the crater, Charlie noticed a tiny heap of fresh, dark soil. What could have survived the torrid heat so close to the eruption center? A tiny rodent, a northern pocket gopher, had survived in an area where most life had been obliterated, and its lush green habitat had turned into a moonscape. Many gophers may have been unaware of the inferno unfolding above ground and continued their activities deep in their protected burrows. During the summer of 1980, the gophers were able to survive on a diet of roots and remnants of plants that had been destroyed by the eruption. But the question was, would this little mammal be able to survive for very long on the devastated land? Would vegetation ever return to the slopes of Mt St Helens? The zone that suffered most is the pumice plain. Here, super-hot gas-charged flows of pumice surged from the crater at high velocities for hours, creating a vast, sterile surface of steaming pumice. Blocks of glacial ice buried beneath the pyroclastic flows melted and exploded into steam, dotting the plain with craters.
Back in 1982, a few of us were flying in a helicopter low over this landscape looking for any form of life. And we saw a single lupin plant right where we sit right now, in fact, right here behind us within a meter. We set the chopper down and we came and investigated, and sure enough, it was a prairie lupin.
How then did this plant get here? And why was it able to grow in this hostile environment? The seed that initiated the first lupin plant probably arrived by wind from surviving plants high on the volcano's eastern and western flanks. Charlie made another fascinating discovery. The prairie lupin and the pocket gophers joined their pioneer efforts. The pocket gophers are fond of lupins. While they burrow through the developing soil, the lupins provide a reliable, highly nutritious food source. Certain bacteria in their roots enable them to process nitrogen from the air, so lupins can fertilize the soil from which they grow.
In many respects, the northern pocket gopher was a hero in the early days because what it did is it created heterogeneity and increased the biodiversity, essentially initializing the steps of forest recovery. You would have the gopher living beneath the mantle of ash in this old, very rich in nutrients and other important constituents of soil, and churning those and bringing them to the surface and mixing this very rich growing medium with the inert or impoverished volcanic material, creating an ideal soil for plants to grow.
So the gopher's digging action improves conditions of the volcanic material for recolonization by plants. Within just 2 years, the lupins enriched the soil with nitrogen and carbon so that other plants could also successfully establish. Half a decade after the devastation, Spirit Lake was again set in colorful wildflower meadows. The flowers were followed by insects. Tiny oases appeared, alive with scurrying and humming creatures. The new vegetation now offers cover to common nighthawks that raise their young among the lupins. Over the past 30 years, Charlie Crisafulli has spent more than 1,800 days around Mt St Helens, monitoring the re-establishment of fauna and flora. A photographer friend has taken thousands of photographs. These images visualize the return of life after death. Today, the initial stages of forest development are spread all around the foot of Mt St Helens. Willow shrubs offer ideal hiding places for small mammals. Charlie catches them in traps with bait made of peanut butter and rolled oats. Carefully, each animal is listed and described, so the scientists can establish which species colonize these islands of life and when.
So one of the most astonishing findings at St. Helens was in these oasis habitats that these small mammals could make it to this site. One would speculate that how could they possibly traverse this barren landscape, but indeed they do so. So clearly, our understanding of the ability to these organisms to disperse was greatly underappreciated. And indeed, they're capable of traversing great distances, and we didn't realize that.
These are Pacific jumping mice. After counting, measuring, and weighing them, various aspects of their biology can be understood. Roosevelt elk are among the most successful pioneers at Mt St Helens. They quickly recolonized the open landscape around the volcano. Year by year, the herds grow. Under the watchful eyes of the adults, this newly born calf takes its first shaky steps. The rutting season is still a few months off, but this male already takes interest in the females. The elk also play an important role in the process of regeneration. Their hooves shatter the hardened crust on the surface, so rain and snow can mix the ashes with organic matter. In their hair and dung, the elk bring in plant seeds. In this way, they sow their own future pastures. Mt St Helens was monitored even before 1980. But since the eruption, experts of the US Geological Survey have recorded the slightest tremors. To watch the huge growing lava dome inside the crater, geologist John Major regularly visits the site. Around the crater, John and his colleagues have installed a network of high-tech instruments. These devices need maintenance and regular replacement. The crater is a dangerous place. Poisonous gases seep from cracks, and falling rocks are a constant hazard. This is John Major's workplace.
We use a variety of instruments to monitor Mt St Helens in order to get a sense of when the mountain might erupt again. As magma starts to move, it will break rocks, it will generate earthquakes, and our seismometers will detect that. As magma starts to move, it has to push a lot of that rock that it's moving through out of the way, and when it does that, it causes the mountain to deform a little bit, and our GPS units allow us to measure that deformation.
Soon after the eruption, in the heart of the crater, a rebuilding process began. Hot lava was pushed up from the depth of the mountain. Earthquakes shook the ground, sending clouds of ashes into the sky. By the mid-80s, a lava dome as high as the Empire State Building had risen in the center of the crater. In 1986, the dome stopped growing for the time being. When the mountain exploded, the hot pressure wave was accompanied by a huge avalanche of mud and rock. Both hit Spirit Lake. Fish and other aquatic creatures quickly succumbed. The lake became grossly enriched with organic material altering its chemistry. Soon oxygen was gone from the water. The crystal clear mountain lake turned into a poisonous brine. Tens of thousands of trees still float on the water. They were torn from the slope on the opposite side. This vast carpet of dead trees makes the lake unpredictable. Even the slightest breeze pushes the timber from one bank to another. They can block a vast bay for days on end. Most Douglas firs and cedars stayed afloat. Hemlocks and true firs have sunk to the bottom, forming a spectacular underwater landscape. Charlie Crisafulli has documented the slow but steady recovery of the lake.
By 1983, or 3 years after the eruption, oxygen began getting into the water column. The water cleared. The water was so black initially you couldn't see your fingers if you were to wiggle them. But say a few years later you could see down a meter, and that only increased. And with that increased light transmission into the water column, oxygen began becoming more plentiful because phytoplankton, the basis of the aquatic food webs, had colonized. In fact, 135 species had colonized. And that set the stage for many other organisms to enter, such as zooplankton, tiny organisms, animals that feed on phytoplankton, and insects. And before long, the life was teeming with a much more typical group of life forms than you would expect in an undisturbed lake.
When Charlie casts his nets, he finds more and more water fleas. These tiny crustaceans are quite sensitive to water quality. Their comeback meant that just 10 years after the eruption, the lake had recovered its water quality. Far sooner than the scientists had predicted. Underwater vegetation also returned quickly. Soon the lake floor turned green. In the mid-90s, a sensational discovery is made. A rainbow trout. How did this fish get into the lake? The notion that a few individuals may have survived the cataclysm can be ruled out. The water had been compromised to a point that no oxygen-breathing organism could live. In the following years, Charlie began to systematically investigate about the fish. But instead of solving the riddle, more and more questions arose. All the fish he caught were 2 to 5 years old and very large for their age. Their size can be explained by the lake's productivity, but the fact that young fish are almost missing still keeps the scientist guessing. Did the fish originate from other lakes higher up in the mountains that are connected by streams? Studies have shown that this is not a valid explanation. These lakes are not inhabited by rainbow trout. To discover their origin, Charlie began his own research.
Okay, we have a beautiful male here. Very bright coloration. Snout fork, it's 495. He's a very slippery fellow.
A genetic analysis of tissue from the caudal fin is to show whether these fish are related to the former inhabitants of Spirit Lake, or rather to fish of nearby rivers.
All right.
But even this genetic test has not produced clear results. The origin of the new rainbow trout remains one of the unsolved riddles of Mt St Helens. "15 years after the cataclysm, the monotonous grey has turned into a tender green. Today, sporadic young trees dot the slopes. Around St. Charles Lake, the hilly land surface prevented the pressure wave from spreading as a uniform front. Here, nature did not have to start from zero.
This entire basin was spared in many respects from the full force of the blast. The way it did that was because we have this ridge, and the blast actually hit it and was deflected over. Some of it was funneled into the basin, and you can see that by the orientation of the trees that swirled around this basin with this blast pressure wave that followed the contour of the landscape. But also, all of these trees that you see, these conifers that are now perhaps 7 or 8 meters tall, were small seedlings beneath the snow-protected landscape, and so when it came through, they were thermally protected from the blast wave.
Just 1 year after the eruption, birds began to settle near the mountain. Northern flickers were among the first who used the dead trees for nesting. Today, dozens of bird species have returned to the foot of the volcano. Ground squirrels and marmots have joined them. Even little chipmunks have traveled over long distances. In May 1980, many of the mountain lakes were covered by ice and snow when the pressure wave raced over them. For many plants and animals, this icy cover was a lifesaver. What looks like a tiny dragon is in fact the aquatic larvae of the northwestern salamander. When Charlie studied these strange creatures over recent years, he noticed a dramatic change in their development. Normally after 15 months, most young animals lose their gills and leave the water in order to live in the shade of ancient trees. But these trees were destroyed, and with them critical salamander habitat. Now, more individuals do not undergo metamorphosis, but reach sexual maturity without leaving the water.
When looking across all the different ponds and lakes at Mt St Helens, and particularly the newly created lakes and ponds, what we see is a very high frequency of these mature aquatic forms, far higher than we would expect. And so we think it's very likely, and it appears, that this larval form has been a strategy allowing this species to persist, particularly in these newly created environments where the terrestrial landscape is so harsh.
Those individuals that do lose their gills have to deal with all kinds of adversity. Salamanders need shade and moisture of a forest undergrowth, but here the sun is merciless. This individual needs to find a shady place very soon. In recent years, new lakes created by the eruption were also colonized by salamanders and toads. How were these tiny amphibians able to overcome the great distance across this apparently hostile, barren landscape? All this shows how complex and interlinked ecosystems can be. Roosevelt elk and northern pocket gophers play a major role in helping salamanders along. The rodents, on their part, are constantly busy digging a network of tunnels in the ground. During their frequent movements across the landscape, the elk keep breaking up the tunnel systems of the gophers. These holes in the ground are welcome resting places for amphibians in need of shade. Down here, it's 10 to 15 degrees cooler than on the surface. Northwestern salamanders are not the only ones who can appreciate these caverns of coolness. In this hole, a huge western toad is feeling quite at home. On this occasion, the hole is full, and so is the toad. The pocket gophers don't seem enthusiastic about these visitors. As soon as they notice light, they start repair operations. Since the mid-90s, salamanders have benefited from the gophers' activities by using their tunnel systems to disperse from Spirit Lake after metamorphosis. In the northwestern US, winter comes suddenly. The first snow generally falls in late November, and the area remains covered with snow for almost half a year. The eruption has changed the local climate. Snowpack depth and duration, wind speed and light regime. The area that used to be forest and is now the pumice plain used to be covered by several meters of snow. Now, just a few centimeters of snow cover this area. the lake itself has changed dramatically. The driftwood prevents its surface from freezing over, in spite of sub-freezing temperatures. In the crater, however, there's snow and ice galore, forming a massive glacier.
In this picture, we see the 1980s lava dome, and we see the glacier ice wrapping around that lava dome. And you can see the arms of the glacier that have then flowed around the sides of the 1980 lava dome. In a later picture here from 2005, we can see quite a dramatic difference. Here you can see the new lava dome that is growing between the 1980s lava dome and the crater floor. And you can see how the glacier ice has been squeezed and advanced towards the front of the crater. The current state of the glacier is such that the west arm of the glacier and the east arm of the glacier have now joined.
The Crater Glacier on Mt St Helens is North America's youngest glacier. In summer, dust and debris protect it against the sun. This has enabled it to grow to a thickness of 150 meters. When Mt St Helens' northern flank slid down on May 18, 1980, most of the material rumbled through the Toutle River Valley. Today, the old valley floor lies beneath under up to 200 meters of volcanic debris. The creeks and rivers had to carve new beds into the surface. An entirely new landscape has been created, one dominated by pools and lakes. Here too, the birds have been the first to exploit the raw habitats. Just 6 years after the eruption, nature's most efficient builders have left their mark on the landscape. Beavers are back at Mt St Helens. Their dams slow down the current and dampen the fluctuations of the water level. In the backlog above the beaver dams, plants can grow, and beavers feed on them. The quiet pools between beaver dams are an ideal habitat for amphibians. All across the globe, amphibians are under threat, except around Mt St Helens. Here, they truly thrive. Each spring, the lakes and pools are teeming with millions and millions of tadpoles. The offspring of the northwestern toad invades the water around the volcano. Inevitably, this abundance of life attracts hunters. Common garter snakes chase after the little tadpoles. Lake shores are covered in lush grass, and dense shrubs offer cover to the elk. "30 years after the eruption of Mt St Helens, plant and animal life has reclaimed the devastated land by fits and starts, boom and bust population cycles, and random processes. Above it all rises the volcano, a constant reminder of the Earth's forces." Mt St Helens is not extinguished. On the contrary, again and again over the decades, it has shown signs of activity. John Major has documented this activity with time-lapse cameras. His images show how enormous forces push up hot rock from the crater floor to the height of a skyscraper. From 2004 to 2008, another lava dome builds up, spacious enough to contain several cathedrals.
Eventually, the volcano will build itself back up, but that may take many hundreds of years to maybe a few thousand years to attain its pre-1980 form. But the history of this volcano suggests that probably over the next few decades to centuries, we may see continued lava dome growth.
Since 2008, the volcano has been quiet again. The pressure inside has not been sufficient to lift up new masses of rock. But that could change at any moment. Once upon a time, there was a mountain that blew its top. A paradise was lost, but as the years went by, plants and animals came to claim it back. The great heroes in this story are a little lupin flower and a little pocket gopher, the very first pioneers in a land of destruction. This is not a fairy tale, but the true story of life after death. A resurrection on the slopes of Mt St Helens. Not just a tale with a happy ending, but a never-ending tale. As this thrilling story goes on, Charlie Crisafulli and John Major can't wait to see the next chapter of Mt St Helens Chronicle unravel.
I would love to see another eruption occur at Mt St Helens, because for 30 years this has been a rich laboratory where we've learned so much about the way in which plants and animals respond to a volcanic eruption. So for all of the hypotheses that we've developed and predictions and models, we could test again in this landscape and continue this fabulous living laboratory.
But the last word on that belongs to Mt St Helens.
It's not a matter of whether if it will erupt again, it's a matter of when it will erupt again. When will it reactivate? When will it reawaken? And if it reawakens again, what kind of eruption will it be and how big will it be?